Welcome friends. Today we are going to be discuss the topic of properties of matter and non-destructive testing. In this unit, we are to discuss on fluid frictions, second part. That is Archimedes' principle. When the body submerged wholly or partially in a liquid, it expresses as a part loose in its weight, which is equal to the weight of the liquid displaced by the body. The picture can show that here now when 5 kg weight attached with this measuring instrument, this 5 kg weight dipped in the liquid. So we can see that the weight of that liquid is that the weight of that measuring instrument showing as 2 kg only, and the displaced water is in 2 kg. So Archimedes principle says that when the body immersed partially or wholly in the liquid, they can lose their weight. So this is the Archimedes principle, and lose of weight is called as buoyancy. So the applications of Archimedes principle you have to see in these pictures like this. Ship can travel. Ship in sea, you have to see that they can displace the liquid when they are wet. So next point, that is viscous force, an internal force developed between two layers of liquid that opposes the relative motion that opposes the relative motion between layers of liquid is called as viscous force. The picture can see at here now that can opposes the relative motion between two layers, that is the viscous force. Viscosity, the property of virtue of which a liquid opposes the relative motion between the layers is called as viscosity. Then second, that is velocity gradient. It is defined as the change in velocity per unit change in distance in liquid layers. So velocity gradient is equal to dv by dx. dv is nothing but the change in velocity and dx is nothing but the change in distance between two liquid layers. The unit of velocity gradient, that is nothing but the per second. Newton's law of viscosity. So Newton's law of viscosity says that the viscous force F developed between two liquid layers is directly proportional to first one, that is surface area A of liquid layers, and number two, velocity gradient. So formula can see at here, the force is directly proportional to A and force is directly proportional to dV by dx. So dV by dx is nothing but the velocity gradient. So we can if we can merge these two statement, so the F is directly proportional to A into dV by dx. So we can eliminate this symbol, directly proportional. We get the coefficient of viscosity eta. So F is equal to eta A. A is the area of surface into dV by dx. So where eta is the called as coefficient of viscosity. So coefficient of viscosity is defined as the coefficient of viscosity of liquid is defined as the viscous force developed between two liquid layers of unit surface for unit velocity gradient. So eta is equal to F by A is the area into dV by dx, and the unit of coefficient of viscosity Newton second per meter square, like this. Stoke's law, the force of viscosity expressed by a small metal surface falling freely through a viscous medium with terminal velocity is directly proportional to radius of metal sphere, terminal velocity, and coefficient of viscosity of liquid eta. So F is directly proportional to eta into R into V. So we can get again F is equal to 6 pi eta R into V. This is the Stokes law formula. Next, that is derivation of coefficient of viscosity eta by Stokes method. When suppose a small metal sphere of radius R and density D is freely falling under the gravity of viscous fluid of density rho. This is the liquid and this is the ball or ball bearing or the small metal sphere falling through this liquid column. So all the derivations are like this. So metal sphere express three forces. First one, that is weight of metal sphere in a downward direction. This is the metal sphere can go in downward direction. So the weight of metal sphere in downward direction. Second, force of viscosity in the upward directions. So force of viscosity that can opposes the relative motion in this liquid. So that can opposes this one upward direction. And third one, upthrust force in upward direction. Upthrust force is that force that can lose their weight in the liquid. So that force is called as upthrust force. So weight of sphere 4 by 3 pi r cube d into g. Force of viscosity 6 pi eta r into v. So upthrust force is equal to weight of equal volume of liquid displaced by sphere. स्पेयर की वजह से जो लिक्विड डिस्प्लेस हुआ है उसका वेट, दैट इज वेट ऑफ अपथ्रस्ट फोर्स, दैट इज विद द हेल्प ऑफ आर्किमिडीज प्रिंसिपल. जब कोई लिक्विड में कुछ ऑब्जेक्ट गिरता है तो उसका वेट लूज होता है, और वेट कितना लूज होता है, तो वो जितना लिक्विड डिस्प्लेस करता है उससे उतना उसका वेट लूज होता है. सो दैट इज द अपथ्रस्ट फोर्स is equal to lose of weight of body in the liquid is equal to volume of sphere g into density of liquid. So upthrust force is nothing but the 4 by 3 pi r cube g rho. G is the gravitational force, rho is the density of liquid. This is d is the density of metal sphere. So the metal sphere fall with the constant velocity, and then total upward force is 2 downward force. So the force of viscosity plus upthrust force is equal to weight of metal sphere. So using these three equations, we get this one 6 pi eta rv plus 4 by 3 pi r cube g into rho is equal to 4 by 3 pi r cube g d into g. So like this we can calculate. So final equation is eta is equal to 2 r square g in bracket d by rho divided by 9 into v. So r is the radius of metal sphere, g is the gravitational force, d is nothing but the density of metal sphere, and rho is the density of liquid, v is the terminal velocity in the liquid. So the effect of temperature and adulteration on the viscosity liquid, the temperature, when the temperature velocity of liquid is affected by its temperature, the viscosity of liquid decreases with increasing in temperature. When we increase the temperature of liquid, the viscosity of the property of liquid can be decreases. Adulteration, that is nothing but the liquid adulteration means mixing of some other material with the liquid, and adulteration of soluble substance is added to the liquid, its viscosity increases. When the sugar is dissolved in the pure water, then the viscosity of net solution is increases like this. Thank you.